Welcome back to Algebra 2, Chapter 5, Section 1 in this book. And some of you are going, what happened to the rest of 4? It's too deep. You can learn all that stuff later. We don't have time. This is normal. The other math classes I teach are 12 chapters. This one's 14. They throw in a lot of stuff that wasn't in Algebra 2 when I was in school, like statistics and matrices and stuff like that, and even some physics stuff with graphing trig functions. And if we're gonna at least touch on all of them and not take a whole year to do it and not have to work all summer, we got to keep moving on. All right. So I was singing a song from the 80s in my head that maybe you are too now. Who knows? All right, so we're talking about quadratic equations, quadratic functions. And this should be a review. If not, and if I do it too fast, you know what to do. Go find the Algebra 1 video and watch it. Okay, so quadratic functions, or go to Khan Academy or something and go watch some stuff on quadratic functions just to remind you, because I'm sure you've done this if you're in Algebra 2. Alright, so a quadratic equation has an x squared in it. It only needs 1 to be classified as quadratic, so y equals x squared is 1. Now you could have the whole thing, something like x squared plus 6x plus 3, where it has a x term and a bare number. But it doesn't have to have it. But all of these, though, if you graph them, are shaped like a parabola, a sort of a U-looking thing. If the a term is positive, like right here, see how that's not negative? The u goes up. If a is negative, the u goes down. Now, one way to graph it is there's this little formula. The x-coordinate of the vertex, the bottom of the valley or the top of the mountain here, is equal to this formula. So it's x equals negative b, so like this would be negative 6 over 2 times a, and this one it's 1, because the terms is, I'll write it up here, let me get a thing. Whatever is the coefficient of this is a, this one's b, and this one is c, and you're going, wait, but there's no number there. It's an understood 1. So a is 1, b is 6, c is 3, all right? And this is also the axis of symmetry. You can draw a little dot there, and it's symmetrical on both sides, a little dotted line, and that is going to be wherever this equals what this x equals. What did I say this one was? It's negative 6 divided by 2, it's negative 3. So that thing would be this if it's at negative 3 on the x-axis. So that's y, that's x, like that. Okay? Now then, I'm going to show you the way your book shows you, which is the 1987 way to graph these things. So it says graph this. First we identify the terms. That's the a term, the b term, and the c term. Next we figure out what the vertex is. So we do negative 8, and 2 negatives make a positive, over 2 times 2, which is 4. So the x term is 2, and the axis is symmetry. So I know that my u is going to look like that. Next, I would figure out what the y is that goes with that x. I know it's on x equals 2, but I don't know up or down. So I go and I fill this 2 in where those x's are. And you can write it in your calculator exactly like this. 2, beginning parentheses 2 to the second power minus 8, beginning parentheses 2, in parentheses plus 6, and bada bing, bada bang, you get negative 2. So we know this is the 1 point. 2, negative 2, and we put a dot there. And then you say, well, what about if it's 1? You go in and you say 2 times 1 squared minus 8 times 1 plus 6, and that's 0. And then you go, well, if this is 0, probably the same distance on the other side is 0. You try 3 and it's 0. And you keep doing that until you get enough points to draw your parabola. Whoop. Okay. That's not how I want you to do it. It takes too long. I want you to understand it, but this is 2020, baby. So we're going to do it 2020 way. Number 1, we're going to put it in our calculator under y equals 2x squared minus 8x plus 6. We're going to graph it. We're going to hit that graph button and look at it. If it's not showing up on our window, we're going to go back and hit zoom, and I would probably do zoom standard. You can also try zoom fit, but you get weird looking parabolas. I do zoom standard and see if it shows up. Then I'd say second trace, and then I'd find the minimum because I know that this is a shape like this, so I know it's going to be a valley, and I can find the minimum. It will have me make a little line on both sides, and then it says guess, and it tells me that this minimum point is at 2, -2. Sometimes we'll say 1.999, but it's 2. Another way you can do it, I have a program on my calculator called Aquadee. It's not really, it's Quadratic Equation. And you put in, it says A question mark, and you say 2, B question mark, -8, C question mark 6. You hit enter, and it tells you the vertex is at 2, -2. And so once you have your vertex, then you can add more points to it. And how you add more points is you go back to your graph where you put this in for y1 under your graphing calculator, you graph it, then go back to graph, say trace, and you just tell what you want to try for your if-then chart. You put in 2, it says -2. You put in 0, it says 6. You put in 1, it says 0. Now if you put in like 3 and it says 0.2497, go on, don't do that one. And then 3, 0, and you get points, you write your points down and you draw it. So we're going to work off of the calculator. You'll put it in, you'll get your points, you'll put your points on your piece of graph paper, you'll draw it. So you can generate your if-then, your points off of your calculator. Now, I show you calculator labs to do that. Be sure to watch them. It's where I zoom in on the calculator real close and show you how to do all of this. That's what I want you to be able to do. Because when you're in college, they're going to want you to do a bunch of problems fast. And I want you to be able to work backwards off of your calculator. All right, understand 1987, but they gave us time to do it. They don't give y'all time anymore. They expect you to do it faster using your calculator. All right, so how about this one? What if we're going to graph that? 1987, we would multiply it out and do all of this. But for 2020, in the 2020s, you just type it in exactly like this, and your calculator can graph it. Your calculator does not have to have it in standard form. Your calculator is absolutely fine with this form. You just do negative, beginning parentheses, x plus 2, in parentheses, beginning parentheses, x minus 4, in parentheses, graph. Bada bing, bada boom, you got your graph. Then get your points off of your graph using your calculator and then graph it on graph paper. Put arrows on the end, plot points. Make sure it's neat. Make sure you've got your if-then chart. But I want you to be able to do that. Now, the next problem, they want you to turn this into standard form. So we're going to have to use the distributive property. We'll multiply x times x and get x squared. X times 5 is 5x. 3 times x is 3x. And 3 times 5 is 15. I draw my arrows every single time. Always. The reason why is, if I miss a problem, it's not because I didn't understand the math. I'm good at math, I understand it. It's because I was sloppy and I forgot to multiply something. So the number one thing for me is organization. And I found that I'm not the only one. As a math teacher, I found when students miss it, usually they understood the math and they just were disorganized or messy or something. All right, so now this isn't it. See how I have 2 x's here? I have to sing and dance. Gathering up my terms. This one's 2 on each side. Stowing away the time. That's the song we sing and the dance we do. You can only add or subtract things if they have the same letters with the same exponents. So 3x plus 5x is 8x. That's the answer. Now then, another thing, this is factored form. And what is considered the answer to quadratic equations is where it crosses the x-axis. So this one, the solutions to this are 3 and 0 because that's where it crosses. If you have something like this in factored form, the solutions are the numbers here, but the opposite signs. So it's -3 and 5 and -5. So we'll talk more about that later. It's also called zeros. You can get them off of your calculator under second trace. You can get them off of a program, a good quadratic program like A quad, B quad, or Discremi if I'm giving you your programs. Alright, here's another one. They want us to put in standard form. And what I decided to do first is multiply this x, this negative times x and negative times 4, and I got negative x, negative 4, and then I multiplied them. X times negative x is negative x squared. Negative x times negative 9 is positive 9x. Negative 4 times x is negative 4x, and negative 4 times negative 9 is positive 36. I gathered up these terms and got the answer. Negative x squared plus 5x plus 36 equals y. They gave us this one. It looks mighty fancy, but it's not that hard. Just remember that x squared is x minus 1 times x minus 1 again. Anything times itself. Next, we're going to multiply out these two. So that's x squared, and that's negative 1x, and this is negative 1x, and then that's positive 1. Negative 1x and negative 1x is negative 2x. So next, I distribute this. Whoop, whoop, whoop. It's more fun with sound effects. 3 times x squared is 3x squared. 3 times negative 2x is negative 6x. And 3 times 1 is 3. Now what do? Sing and dance, gathering up my terms. So 3 plus 8 is 11. And there you go. So this isn't hard. Hopefully this is a review. You might not have learned how to use your calculator as much in your algebra, but I think that hopefully it's all coming back to you. And if not, it's not too hard. Watch this video, do your homework, use your calculator, and come back and we'll talk more about factoring. Math is great.